What's up, guys? What's up, Carclad? What's up, TV Late? What's up, Jaha? What's up, Just Your Local Golf Ball? What's up, Redick? What's up, Footwing? Let's see. What's up, Well in Short? Absolutely love what you're doing. Thank you. You said greetings from Germany. Much love to Germany. What's up, Kevin? All right. What's up, Redick? What you got for us today? I got some updates, got some upgrades. Listen, guys, I know it's been a second since I've been live because I've been working the hell out of this electronics cabinet you see here. This cabinet is very, very sophisticated. A ton of safety features put into this, but very important. Way neater, okay? Electronics are the most important part of this machine because, as we know, this machine uses microwaves to turn plastic into fuel, right? And with that, microwaves operate off of electricity. And this machine, thus, is going to consume a lot of electricity. You got to make sure all that stuff is set down right. I'm proud to announce, guys, that I do have a functional power meter built into the power supply. So now I will be able to let you guys know. In fact, I'll let you know how many, what the wattage that we're pulling now on the machine is, the power consumption right now. So right now we have 5 magnetrons on out of 6, because my 6th one's been giving me issues. I might have to replace it. But let's see what the power consumption is right now. I'll tell you guys the exact wattage. We are currently pulling 98,000 watts. So what is that? That's 9.8 kilowatts. Okay, so definitely a lot. We're pulling about 41 amps. And this is everything. This is not just the magnetron. This is the fan, the water chiller, the recovery pump. Everything is on the same circuit. So all of the energy consumption will all be added up together. Even the plastic shredder is on the same circuit. So when I go to do my calculations to let us know exactly what the energy consumption is, it's going to be dead accurate because everything is a part of the same circuit. So I've had the machine running. I've had it running inconsistently for about 30 minutes now. And I say inconsistently because I've turned it off a few times, trying to figure out what's been going on with my 6 magnetron. We do have some oil starting to form out this machine. But, as we all know, we gotta wait for that temperature to start to get up before they really start coming out. So, you guys really want to oil up with Nature Jab? Who wants to party with Nature Diddy? Who wants to party with Nature Diddy? I got some oil for y'all. It's coming up. Y'all just wait a little bit, okay? Then the entertainment's gonna get real in this business, okay? Because I already see some few drops of oil coming out now. But it really starts to pick up once the body temperature of the machine hits at least about 100 C. Right now it's at 92 C. So do the math, almost there. You said close to 150K, congrats. Also, yeah, that reminds me. I gotta thank everybody, okay? Look. Thank you all, we got it. We got it, y'all. 100,000 on the, honestly, I'll tell you guys something, okay? I never thought I was going to hit 100,000 on YouTube. And I'll tell you why. There was a time span for about 2 years where YouTube had me hard shadow banned. And I think it's because they thought I was teaching people how to make a bomb. Because I made a video called My Reactor Blew Up, right? And then ever since that video 2 years ago, my channel just got shut down, like with views and everything. And it took up until now for things to start kicking up. But now we're doing it now. So much love to you guys everywhere. I appreciate all your support. Thank you, Competition Frenchies, for the badge. What's up, Zach? Road to 1 billion. Yeah, first channel to hit 1 billion right here, guys. We're on the way. So, guys, we already got a ball full of natural gas made from plastic waste right here. Now, here's the thing. here's the thing, guys. You have to remember, I have a few options. I can put the natural gas I make right into a propane tank, like right off the machine, thanks to the recovery pump. Or, thank you, Reem, for the donation on TikTok. Much love to you. Or, I can fill up a bladder like a yoga ball. Right now, I'm filling up this bigger bladder right here, my rectangular ball. That's right. You heard it right. Nature Diddy got circular, spherical, and rectangular balls. Thank you for another badge competition, Frenchie's back up. Much love to you, man, on the Instagram. What's up, John Rose? So, also, that reminds me, guys. All right, so we're at 98C right now. So, well, I do see some oils dripping, but it's about to hit to the point where the oils really start dripping. That's good. But let me show you guys the oil we have made in the past runs and what the plan is. So this is the oil we've made of past runs. Notice how it's black. Like me. Black as hell. So what are you going to do with this, right? Well, don't want to put it in the sun. It's only going to get blacker, right? No, I'm just playing. But we have to refine this because this has fuels in it, but you don't want to put this in your engine, right? You want to refine this because this has gasoline fractions, diesel fractions, jet fuel fractions, but they're all mixed together, right? Obviously. Engines doesn't work like that. You got to separate it out. Just have the pure gasoline, pure jet fuel, pure diesel. Well, how do you do that with a distiller? And if you look behind you, you see that thing up there? It kind of looks like a Six Flags ride. It's way in the back. That thing going up and down. Not this big set of pipe, but the one beside it, right? That's the distiller, okay? And I need to get enough of this stuff first to put in the distiller. This is 500 mil. I want to put at least 2 liters in there. So we need about 4 of these worth. Thank you for the badge, Memory. He said, can you send a document with everything? Well, pretty much everything is documented on my YouTube channel. So anyways, I want about 2 liters of this stuff to distill at once to make it the most worth it. And I'm going to distill it with the natural gas I've made from this process. Competition Frenchies, thank you for another badge. So right now we have a relatively small batch of plastic in this machine. I wouldn't say it's anything crazy. Once again, the machine is also, we are missing 1 magnetron, unfortunately. Well, we're gonna fix that stuff tomorrow. It's been a lot of stuff. Because let me tell you guys what happened, okay? And all the electricians in the chat are about to be mad at me, okay? I'm gonna tell you guys something that's gonna make all the electricians mad, okay? And those of you that don't know electricity, it's just gonna sound like a bunch of gibberish, okay? Listen. This is a 50 amp circuit, right? This whole electronics box is 50 amps, right? I read online that you could use 8 gauge wire for a 50 amp circuit. So I had my main wires that go and feed everything 8 gauge. I ran the machine yesterday for the first time at full power, nearly 50 amps being pulled, and I almost had an electrical fire happen, okay? So I had to get bigger wires, 6 gauge wires. That's the norm, the standard. I read somewhere you can use 8, so I was like, oh, you can use 8. But clearly I was wrong because I almost burned down my damn electrical box the minute I turned the thing on for the first time. So anyways, we solved that issue. 6 gauges can go up to what, like 55 amps? We're not even going up there. The circuit breaker would trip before. You said 2-0 welding wire? Yeah, that would be overkill. But, you know, I guess it's always better to be overkill than underkill with electricity, right? So, yeah. I almost had an electrical fire happen in that box. In fact, I'll go get the breaker. I'll show you what happened to the breaker. Thank you for the $5 donation on YouTube. Larvy, XD Larvy, much love to you, man. Let me go get the breaker to show you guys the remnants of the fire. So fortunately, the only thing that got damaged was the actual wire and then one of the breakers. It was a 2-pole breaker, but look at it. Got burnt up, right? Y'all wonder how I got so black. The electricity did it to me. I used to look like Kurt Cobain, got electrocuted. Now I'm black. I can never go back. Oh no. So yeah, that's what happened. But everything's been sorted out. Everything's been fixed. The machine is not running at full power right now because, like I said, one magnetron is out, which is about another 5 amps. But we are pulling a 42 amps right now, and everything's running fine. So is that too much for the breaker? These breakers are supposed to be rated at 50 amp. This is a 50 amp breaker, 400 volt AC. So yeah, whatever. I got different ones this time around, but. And also, Zach, thank you for another badge on the Instagram, man. Much love to you. And the previous badge, I didn't see when you had bought it. You said, did the neighbors ever say anything? People always ask that. Fortunately, I haven't had that issue, but another good thing is I'll actually be in a different location pretty soon, guys. I'm not going to say where, of course, for my own safety, but I'm going to be in a better location for this whole project very soon, okay? Thank you, Competition Frenchie, for another badge on the Instagram. Much love to you. Yeah, because honestly, guys, I'm tired of putting my calc on everything. And I'm tired of having to cover up stuff every time I know it rains. I'm tired of having to freaking watch the forecast like God, believe man. And I'm tired of having to watch the forecast as if I'm like Drake watching the preschool, you know what I'm saying? Like, I'm tired of having to pay attention to all this stuff like that, you know? So we're good. We're gonna get it. We're gonna get in a way better location, in a weatherproof location, and we're gonna be good. So now that we do have a way to track the electrical consumption, well, how in the world? Actually, I want you guys' advice for this, okay? Because in the past, when I did my calculations on the energy output, it was between the carbon product if it was burned like coal, the natural gas product if it was burned, and then the liquid fuels. I did the calculations based off of like I was doing the calculations based off of its constituent product. So I took this product here. Thank you for another $5, Larry V on the YouTube. So I took this product here, right? Let's say we made 500 mils from a run. Right? We made 500 mils of this liquid from a run. Well, we know this liquid is a mix of stuff, right? A mix of gasoline, mix of diesel, mix of jet fuel. All those things have different energy densities. I based it off of the lowest thing. So I pretended like this was 500 mil of gasoline. Because if I said this is 500 mil of diesel, but it's half diesel, then you know, but if I say it's 500 mil of gasoline, even if we shoot lower than how much energy is in here, we will not be shooting over, right? Because I don't know how to measure BTUs. Same for the natural gas. I measured, or I didn't measure rather, but I knew I calculated the volume of these yoga balls, and I converted that to natural gas and the BTUs of natural gas, and then I calculate or multiplied that by how many yoga balls I had. Carbon product was the easiest one. It's coal, you know, carbon. You just say, oh, how many pounds of blank will give you this? And I just added all that together to get my output. But I reckon there could be a better way to do that. That's why I'm asking you guys. What do you guys think is a better way to calculate the energy output of the product, the potential energy of the products coming out? Okay? A more accurate way. How do you measure BTUs? I don't know. That's the most accurate way, right? To literally measure the BTUs of every single thing, right? You said divided by pi? Yeah, exactly. Doing some Albert Einstein shit. All these damn calculations and numbers. You said, what about the net calorific value of crude oil? Oh, that's a good idea, because crude oil is a mix of all those oils. That's good. Thank you. So when we do the calculations, we're going to base it off of that. But then, you know, that's kind of variable too, because, you know, there's sweet crude, sour crude. But we want to we always want to leave a window. We always want to be under. You know what I'm saying? So we always want to leave a window for error that is above, or rather below, how much potential energy is actually in there. Okay, so that way we don't go over. I would rather be over, because if you're under, you can always go up. But if you're over, then at that point, it's just like, well, it's definitely not accurate, right? You said divided by 3. Okay, so you guys are saying of crude oil. Okay, cool. Okay, so we'll do that. Crude oil. Now, the truth of the matter is, in the ideal world situation, I really only want to make up for the energy in terms of the oil product and the natural gas product, because I don't think the carbon or the coal product is going to, like, that. There's way better uses for that product than to burn it, you know. And it's not easy to burn coal anyway. You know, you can't just light it on fire. You can't just put it in an engine. You gotta have a freaking, you know, we don't even have that many coal fire plants like that nowadays anyway. So I would rather the carbon product not be included in the calculation. But if we're talking about net output, you have to include it because it is energy coming out. But if we're talking about usable output, I wouldn't include it in the usable output because we don't use coal like that nowadays. And on top of that, I just think there's way better uses. For example, further refining it and making biochar out of it, right? Or putting it in concrete filler, or putting it in tires and roads. I think there's better uses for the carbon product than to just burn it, personally. And then on top of that, if you burn the carbon product, the process, you're kind of... So here's what happens, guys. Plastic, when it sits out in the environment in the ocean, what happens? When you have plastic out in the environment in the ocean, it breaks down very slowly, we know that, but it also emits gases, ethylene and methane. It emits those two gases as it's in the environment breaking down. Those gases are worse than CO2 by tons, okay? We know methane's 40 to 80 times worse than CO2. Ethylene is about 20 times worse. So plastic emits these way worse greenhouse gases than CO2. This process, of course, makes fuels that will burn and make CO2 when they're burned, but it also converts a portion of that plastic into directly carbon. And that carbon is, well, it's a product that would have ended up in the air as ethylene or methane, which are way worse than CO2 if you had just left it in the environment. But now you actually convert it into a solid, stable thing that's not going to emit greenhouse gases. So that's actually how the process of pyrolysis is carbon neutral. Because look at the actual machine itself. Do you see any smoke coming off? Do you see any flames coming off? No. The only thing in the machine that emits carbon is the consumption of whatever energy, right? Whether that's the solar panels, whatever generator, that's it. But the machine itself does not emit anything. Look, like I said, you don't see anything coming out. Everything's captured. So the process is carbon neutral. If you run it off of solar panels or windmills or hydroelectric nuclear, it's carbon negative, right? So you can make carbon negative fuels through this process. And I'm not saying anything, just say it. You can literally just look it up on Google right now. Is pyrolysis carbon neutral? It will say yes, because it is a carbon neutral process and potentially carbon negative under the right conditions, okay? It also is a Diddy positive process as well. And what does that mean? That means that in this process, you will make things that attract Diddies, such as oils, such as men, and a few other things as well. So, you know, there's a lot of benefits to this process. But I think the biggest benefit that we all have to remember, okay, the biggest benefit we have to remember is the fact that this process is a way to truly get rid of plastic waste. This is not some bull crap, turn one bottle to another bottle and say it's a carpet and then that carpet ends up in the ocean. This is not say that you're recycling it when the recycle truck comes picks it up, but it really just takes it to the landfill. This is not say we're recycling it when we're really just taking it to an incinerator. This is actually a plastic product and turning it into other usable products that are no longer plastic and no longer going to make microplastics, okay? I can make 1 million water bottles out of the same water bottle, but I'm going to make a ton of microplastic in the process. I put my plastic in here, it is literally chemically destroyed to a point where it is not a microplastic anymore. It cannot be a microplastic anymore, okay? Oh, also, guys, let me show you something cool. I got a remote for the motor to spin the blades. You said the carbon would be filled with impurities. It absolutely would, just like coal is. So you gotta clean it up. But the biggest impurities are macro impurities. And what does that mean? Well, let me tell you something. The carbon gets mixed with mostly inorganics, metals, glasses, that type of thing, salts, okay? Those are easier to get out than if the carbon was mixed with like oils and stuff. The carbon, when it comes out, when this machine works how it's supposed to, the carbon is dry. It's free of organic matter because the temperature has achieved a hot enough place to where all organics have vacated the carbon. So we're not gonna have forever chemicals, PFAS in the carbon. We're not gonna have oils in the carbon. We're not gonna have plastics in the carbon. When the machine operates how it's supposed to, the plastic is chemically destroyed on a level where it's no longer plastic anymore. And that's period. And then all that's left of the carbon is the carbon and minerals. That's when it works properly, right? If the machine isn't operating properly, then yes, you will have contaminants in your carbon other than inorganics because it was not properly broken down and properly carbonized. And speaking of carbonization, that actually leads me to a question a lot of people ask. I've seen a lot of people ask me, why didn't you make your machine vertical? Why is it horizontal, right? Because it always makes more sense, thermodynamic-wise, to make something where you're making vapors that rise vertical, right? This is horizontal because in order for the blades to do what they need to do, to properly break down the plastic into carbon and not leave behind organics, the blades on a horizontal fashion work better at agitating it and mixing it than if it was vertical. And on top of it being vertical, if there are vertical blades like it was a blender, it would spin plastic into the magnetrons, which would damage them. So horizontal is actually the best design, and I know that for a fact because you can look up big pyrolysis plants, even ones that don't use microwaves, just the big ones, and they're always horizontal. They don't make them vertical like that for a reason, especially if they're continuous. You say, where are you right now? I'm in Georgia. You say, eliminate plastic plus crude oil plus pure carbon. It's not pure carbon. It does have to be cleaned up, but it can become pure carbon. But it is carbon, though. So you got that right. It is carbon, and it probably could be put directly into concrete, as is, because, you know, it actually makes concrete stronger, for one. And for two, if there's like heavy metals in it, it doesn't matter if it's in concrete. There's already heavy metals in concrete. But if we want to use it as like biochar, or we want to use it as something more, I guess you could say food grade, you definitely got to clean it up. Have you calculated the microwave energy use against other heating methods? Do you have issues with some plastics not breaking down with the microwaves? Are you feeding an oil? Wait, are you feeding an oil in with the feedstock? I'm not feeding an oil with the feedstock. I don't have problems with the microwaves not breaking down the plastics when the machine operates how it's supposed to with all the magnetrons on. Thank you, Pablo Valencia, for the badge. Thank you, my giant nads, for the badge. I have not compared it on a number or mathematical perspective to other heating methods. However, research papers have. And yes, microwaves are up there when it comes to pyrolysis. You know, that's just the research papers speaking there. But I have not done an actual clinical comparison. But I have built machines that run off a fire, and I just can tell how the machines operate. Microwaves do work better. Thank you, Bruvux, for the 20,000 on the YouTube. I'm not sure what currency that is, but thank you very much. I appreciate you. You said, hey, Naturejab, at first I was skeptical, but I once remembered that plastic has crude oil in it. So it made sense. Doesn't plastic not absorb microwaves? What about nylon, which is made in other ways without oil? Crankbait, thank you for the $5. So yes, plastic is made of crude oil, has crude oil in it. That's how this works. So it's absolutely possible. It's not even new science. How does microwaves go right through plastics? Thank you for the badge competition, Frenchies. Much love to you, man. So you put plastic in your microwave, it doesn't heat up. How do the plastics get hot enough in here to break down, turn to all these fuels? I mix the plastics with carbon. Carbon does absorb microwaves and makes really hot spots, like 1,000 degrees centigrade type stuff. Very hot. And then that heat goes to the plastic. So that's how it works. Let's see. The temperature's looking good. We got some liquids coming down. Looks like we got mostly water forming right now. So what I'm excited about is to do a true full run. Right now this machine is not operating continuously, unfortunately. I would love it to, but it's a batch machine right now, a big batch machine. And I would like to do a humongous run in here. I'm talking loading in 15 to 20 pounds of plastic in there at once. And it doesn't sound like a lot of plastic, but plastic is so light that 15 to 20 pounds is a lot of plastic. It's like a week's worth of plastic on family, like it's a lot. So I want to know, when we load in that much plastic, how many oils and stuff we're going to get out. These machines operate on the principle, especially with microwaves, they operate on the principle of exponentiality when it comes to the feed. So the more plastics we put in, the further the energy we put into the machine is going to go when it comes to the products we get out, in theory. And in practice, actually, because I built these before, so I've seen that. So as you guys can see, my bladder is filling up. My green bladder, I mean, you guys have been seeing it. You guys have been seeing it right here. We got the yoga ball, we got the green bladder. My propane, I gotta get another propane tank because they're already at 200 PSI. I really don't go above 200 PSI, but I could though. My recovery pump goes up to 500, but that's a little bit too much for me. A little bit scared. So wondering what your carbon return is? Yeah, so that's the thing. Once we get this to the point where we can do that type of thing, we do that type of run, because I got my scale, okay? So here's what I'm gonna ask you guys. I'll let you guys decide, okay? I'm gonna let you guys decide on this. This machine has been designed to run continuously. That means loading in plastic while the machine is running. Okay? Loading in plastic while the machine is running boosts the efficiency a ton, because the energy that you had to put in to heat the machine no longer has to be put into the same degree to heat up the new plastic that comes in. For me to do the energy calculations on the output is a lot of math, a lot of work. It's a big thing to do. Do you guys think that I should do it now that we have the machine operating at full power, or should I wait until I get it continuous? Because technically, that's the fairest to the machine, since this machine was designed to be continuous. You guys tell me. I could do both, or I could just wait until it's truly done. Have you tried turning Legos? I have not, but Legos actually have a lot of, I've done some research papers on, or read some research papers on Legos, and ABS has a lot of fuel products in it. So much so, they actually research it to make jet fuel, like a solid jet fuel out of freaking Legos, ABS. You said both for science? That's good, yeah, that's true. Because if we do both, we have a comparison point to see how much better did it get when it got continuously. Right? So with that being said, what I have to do then is I have to do a few more test runs, okay? Yeah, more data, all right, for sure. So we're gonna do both. I gotta do a few more test runs to get this thing tuned, okay? Because like right now, like I said, one of my magnetrons went out. The circuit breaker keeps flipping. Some stupid crap is happening. How to fix this stuff, okay? We're gonna get this thing tuned, a few more test runs And then I'm gonna do my first clinical trial. How much plastic we put in, how many pounds of plastic in, how many liters come out, how many liters of this, how much natural gas, okay? And then we can, once we have those, we can always calculate the energy on those. And how much energy did it take to turn that much plastic into fuel completely. We're gonna do that first ever clinical thing in the upcoming week or so. Okay, and then we're also going to continue to build the machine, get it continuous, which will be probably about June when this thing's continuous. And then we'll do another clinical run with it operating continuously. And we'll see what the difference is. It should be a pretty big difference because like right now, the machine has a fixed amount of plastic in it. I really can't add more plastic in right now without leaking and causing an explosion and really bad emissions and crap. So we don't want to open up the machine while it's running, or then it will become a complete environmental disaster. It will leak stuff, it will emit stuff, it will not be good. When you keep it closed, you keep it sealed, you're okay. And guys, we got oils, by the way. Is the TikTok lagging, guys? Let me restart it. I think the TikTok is lagging because everybody left. Before I show you guys some of these oils, we got some oils. It looks like a small amount, looks like mostly water. So that's what I'm saying when I'm saying tuning the machine. We got to figure out how much plastic gives you the optimum amount of oil. Should I mix the plastic with the motor oil? These types of things, we tune it. Thank you for the $20 donation. Calliewood28 on YouTube. He said, thank you for expanding the human consciousness. Hey, much love to you and you're so welcome. Thank you for being a part of the project and helping. You said, how's the generator been going? The generator right now, I got it over there. It's on hold right now because I need to focus on finishing the machine first. I was trying to run the generator before I even had my electrics box done. I still was having this thing run off of 120, a million different outlets. So I had to at least get the electronics box done first. Because the generator kept flipping off anyway because there was too many amps being pulled collectively because it was 120. So that was the first step no matter what. Had to get this thing operating off of 220. That's done now. Check. Now I have to run it off of 220, do the test runs, make sure it runs good. We're doing that now. Check. Then we need to get it continuous, okay? We want to get the machine. You said I would donate, but I don't have no money. It's all right, man. No worries. I just appreciate the support of you being here and everybody else too. Okay. Now we get the machine continuous, so we can get the maximum output, energy product speaking. And then at that point, I think it will be time to step into the generator space, right? But until then, it's just going to be a distraction. The machine needs to be finished before we do that because, like, the generator is a whole different thing. Because I realized that when I went to go run the generator off of the natural gas, and it wasn't running perfectly because the natural gas had too much moisture in it. And I'm like, oh, now I got to desiccate it, and I got to do all this stuff. So, like, it's just a whole different field. Should I make liquid natural gas? Should I, there's just so many different factors. I'm like, if I focus on that and go down that rabbit hole, it's gonna distract me from completing the machine. And that's the most important part to complete the machine because you guys need to remember, all of my plastic waste goes right here. I don't put plastic in the trash. I recycle it myself at home. So when I have the machine under maintenance, I get backed up with my own plastic. Right now I'm backed up and blacked up like Diddy came in my house. Give me that black mud, How I had the blade spinning that whole time? Oops. Hey, I love how this machine is wireless. I'm much more comfortable around it because I don't have to, look, all the high voltage is on one side. The electronics cabinet is grounded like quadruple times. So I know if there's a short and everything's on a circuit breaker. It's so safe. The machine is so safe. I got a bare copper wire all across the machine. I mean, I'm not even scared of getting electrocuted anymore. It's a shame because I already got electrocuted and turned black from it when I used to be blonde. But, you live and you learn. At least I won't get blacker, right? Yeah, like, look at all this, mate. Hold up. Look at all this. This is bloody bollocks, isn't it? Look at all this. All my bloody... Look at all my dongles. Look at all my dongles, mate. Tons of dongles. I'm putting them in your mouth. I got all these dongles to operate everything wirelessly. From the vacuum pump, to the fans, to every single magnetron, to the motor. Everything is wireless. But the most important part is not wireless, which is the main power. So no, you can't come up in here and try to hack my machine with your little computers, your little geek computers hacking my machine, thinking you can get in it. Because guess what? The main switch, it can be locked with a physical lock. And I turn it off and you can't get in my machine. So you back off trying to hack into my bloody plastic in the fuel reactor. I remember in like 2020 on the news it said like a meat plant got hacked. So there was like a shortage of meat. And I'm like, how does a meat plant get hacked? You know what I'm saying? But everything's so technological nowadays. I believe in balance, okay? Yes, it's amazing to have it wireless. But guess what? I'm gonna make sure it's not 100% wireless to the point where I'm caught lacking. Because I know that people can hack into these frequencies very easily. This is super easy, okay? To hack into this frequency. But if somebody does, I flip that main switch off or I flip any of the breakers. You can't turn the machine on. Put a lock on it. The whole cabinet locks, okay? Everything locks. Gotta be a few steps ahead. Gotta be perspicacious, okay? That's why we're on the move, guys. We're on the move. You're gonna see the whole setting's about to change. Probably in a month or so. I'm gonna be in a different place, okay? Looks like my bladder is almost full. Oh, let me show you guys the oil. Because we got some oil. Let me show you guys. Gotta get my gloves on and stuff, so give me a second. So, take a look at this. Now, you cannot even see how much oil, because you see the water and oil actually separate. And the rest of the oil is up here in this pipe, which is not clear. Okay? But we have oils. We do have oil. Like I said, this is water, so ignore this. The oils are up here. And this is building live. I'm gonna pour this out so that, because right now, it's just oil coming out now. There's not really much more water. Once the water really comes out in the beginning, okay? Once the water comes out, it's out. So I'm gonna pour this out so that way, when we get the next flask, it's just gonna be oil, okay? Let me go pour this out. Unfortunate, you guys can't see, but there's a lot of oil forming in the machine. Constant downfall, constant pouring of it. At this point, we take note of the temperature, the body temperature of the machine, is about 200 C. Somebody do that. What is 200 C to Fahrenheit? Somebody do that calculation. The vapor temperature is 90 C. Now, I got a really good water chiller, so my condenser pipe temperature is only 7 C. Very cold. Wouldn't want to put your balls on it. About 400 Fahrenheit. Thank you, Julio and Andres. So the body temperature of this machine is 400 Fahrenheit. What does that let us know? Well, this is different. This isn't like an oven. For the body to be 400 Fahrenheit, that means inside of the machine could be potentially double that. Because microwaves heat from the inside out. They don't heat from the outside in. So if the body is 400 on the outside, the inside body could be even hotter. And then that means the surface level of plastic is even hotter than all that. So it's safe to say the plastic is definitely far above the temperature at which the organic molecules completely crack. Because, for example, let me put it down to reference. Let me break it down for you. This is the real plastic challenge. According to research papers, the temperature around when plastic starts to break down is about 500 Fahrenheit. 500, 560 Fahrenheit. If the outside body temperature itself is 400 Fahrenheit, right? That means the inside is definitely above 500. That's just math, right? Because microwaves heat from the inside out, simple math there. So if the whole inside of the reactor is way over the temperature at which plastic breaks down, that's how we get the carbon that comes out the way it is. Because like I said, you guys seen the carbon? It's not full of oil. It's nice and dusty. Veritas, thank you for the $10 on the YouTube. How do you plan on cooling the magnetrons when they are running on a 100% duty cycle? Perhaps water cooling. Water cooling is the best. Right now, I just have forced air cooling with fans. Okay? But yes, right now they are operating at 100% duty cycle as well, thanks to the new power supplies. So that's good. And the machine, by the way, guys, the machine is operating under continuous vacuum. The machine is right now consistently at 15 inches of mercury. Consistent. So we get that benefit of the vacuum as well. And for those of you that do not know, operating the machine under vacuum, which is pretty much like the machine is constantly being sucked, just like my balls, what does that do? Well, it actually allows us to put less heat in to break down the plastics to the same degree. And it also does change some of the products you get on a chemical level. That's some deeper chemistry stuff to get in there that I'm still learning myself. You know, guys, the best investment I can do for me is for me to get a gas analyzer so I can analyze my products. Because it's hard. Like, I can read a research paper and they tell me all these things, the chemicals that all the oils and stuff are. But it's like, well, I have so many different variables. I'm doing this in my backyard, not a lab for one. I have this machine, which they don't have. They have a different machine. I have it under vacuum. You know, all these different variables. So it's hard for me to really say, like, you know what I'm saying? Like the exact, the only way to know is to get these things, and they're expensive. But I appreciate you guys for all your support and the contributions and donations to the project, because once the machine is done being constructed, that's what we can save up for next. But let me ask you something, okay? Because I see all the time people tell me solar panels. And listen, I have nothing against solar panels. They're expensive as hell. Primarily the batteries. Let me check something. Oh, never mind. I can hear the blades, they're spinning fine. The batteries are expensive as hell. For me to get enough batteries to run this machine and all of it, the inverters, all that, I did the math. It's gonna be $20,000 on the low end. The machine at this point has exceeded $20,000. But expensive, cha-ching. Guys, what should I do first? What should we invest into first? Should we invest into solar panels first or a gas spectrometer? So let me analyze the gas, because they're probably going to be about the same price, let's be real, right? You said solar panels are worth nuclear energy. I agree, but You know, solar panels, unlike nuclear energy, is something I can buy and get here. You said a spectrometer. You said used Tesla batteries are $500 each. Oh, that's a good point. I could use a used Tesla battery. But if it's used, that means it's got ran through, right? So it may not be as good. I'm seeing half and half. Look, I know all the more scientific people are probably all on the spectrometer side. But all the people are like, just like, yeah, let's run this off of solar. Obviously, you're on the solar side. It's kind of hard to know, like, which way should I go? Like I said, they're both going to probably cost the same amount, $20,000 to $30,000. Cha-ching. And somebody look up what's the average price of a gas spectrometer? Let me know. Somebody let me know. And I'm not talking about like the budget one. Like I'm not talking about the most expensive one, but just like a good one, you know? Like the one labs use. Somebody let me know what the price of it is. Gotta be a few G's, right? Oh yeah, we got some oils coming out, guys. Said $50. Ain't no way, mate. Yeah. These oils are really starting to pour out good now. Real nice, like. I really like this, because you guys used to know back then. You said the 50K. Oh my Lord, have mercy. I'm gonna have a heart attack. You said 10K. That sounds more realistic. You said $20 on Amazon. If you run this on solar, you're gonna have huge issues with your power factor as the amperage, since the wave will be lagging the voltage sine wave as your entire setup is filled with inductive load. I don't know. So here's the thing. I never did anything with solar before. So I don't know. You know, I know about the waves and stuff, but that's like just like with a generator, right? Like not everything can run off of a generator unless it's an inverter, because the wave is too rough. But you can run solar panels off, you can run a microwave off solar panels, right? And this is a giant microwave, right? So I would think you'd be fine, right? Is it $350? I think 10K is around the range of the spectrometer that I would need. Then I gotta get a centrifuge and stuff too. So we gotta really get into getting this oil product up there. Well, take a look at this, guys. My rectangular testicle is almost completely full, ready to be sucked. I hope you're ready. I hope your esophagus is ready. Because we have that and we have this. Two. It's a 2-for-1 special. Triple double. You said better start your OF page. Yeah, you know, look. I know like we had all this situation happen, and I know like public perception changed, but me and Drake for a while have been talking about starting an OnlyFans page, a collaborative OnlyFans page. I mean, what do you guys think? Would you buy? How much a month would you pay for that? Like me and him, we were thinking of names, and we were gonna name it like the Caramel Chocolate Crunch. The Caramel Dark Chocolate Crunch, you know? We gotta get this donation money in, guys. We gotta get this money coming in. So I liked your algae in the ocean idea. Yeah, I mean, look, people, honestly, man, let's be real, mate. People whine all the time about CO2. I'm like, the solutions to CO2 have been around since the beginning of Earth. Like, of course, we're gonna have CO2 problems when we cut down half of the bloody trees on the planet. And then we have the ocean full of plastic, so algae can't grow. Algae is the biggest absorber of CO2, algae and plankton, and yet those are being compromised because of the plastic. But then people get so focused on burning things when humans have been burning things forever. All the cavemen, all your ancestors have been burning things. They had campfires every bloody night. Volcanoes erupted all the time, emitted tons of CO2. The point was the system was balanced. Okay, we had the algae and the plankton and the trees to deal with this, because there's no amount of CO2 we could ever put out that hasn't already been on the planet before. It's just like the water cycle. Every bit of water that's here has always been here. Every bit of CO2 and carbon that's here has always been here. So you have to have the whole balance of the system. And we have imbalanced the system as humans by destroying the natural environments. So it's not about, like, let's just keep it real. Like, the people do too much. Let's be real with that stuff. Because listen, guys, I promise you, if we didn't deforest as many places as we did at the rate we are, we would not be in this huge CO2 thing that they all say we are in. Right. If it's even as bad as it's said. All right? You never know nowadays. Everybody says a million things. A million different sources saying the same thing in a million different ways. You never even know what the real truth is. But the point is, we can say it's pretty obvious. Of course, there's a lot more CO2 in the air now than before because there's a lot more things burning than before. That's pretty obvious, right? But I think that the idea of there's a lot of these little things people think that would actually solve it. You got to remember how much methane, and first of all, it's not even about CO2, it's about global warming. Okay, global warming is the actual threat. And let me tell you what's far worse of a contributor to global warming than CO2. The CO2 can be pulled out there easily. We've already been through that. Methane is the real thing. Okay? Methane is the real thing, the real enemy. And guess what emits methane? Food waste. Plastic waste. And guess what the biggest waste things in the entire world? Food waste. Plastic waste. And guess what? We still are landfilling like we're some cavemen. We're still just throwing things in a giant pile like we're ancients. Okay? And when you leave food in a gigantic pile, it emits just tons of methane. If you leave it in an oxygenated area, if you compost food properly, it releases CO2, which can be pulled back out the air. You leave it in a landfill, it emits methane. You can't pull it back out the air. You leave plastic out in the environment, it emits methane and ethylene. Can't pull it out the air. Ethylene is literally a refrigerant, okay? Talk about the ozone layer. Guess what? You put plastic in the machine, breaks it down to CO2. That can be put back out the air. So CO2 is never the issue. That's the matter. We have more methane in the freaking air than any time and ever before. There have been times on the earth where there's been more CO2 than we've ever even seen because volcanoes went off. But there's never been this much damn methane because there's never been somebody on earth that thought it was an amazing idea to have a humongous pile of food waste and plastic waste, things that can be turned to amazing valuable products, turn food into compost, use that to grow your food instead of having all these chemical fertilizers that destroy the ground even more and destroy the life within the ground that sucks the CO2 out the air, right? Or turn your plastic into the fuel products you need in the world instead of having to drill in the ocean every time and then have your oil spills that kill all the plankton and algae that were sucking the CO2 out the air. So the CO2 problem got exacerbated by our unethical conservative practices, right? But the true problem is in methane, because methane is so much worse. That's the real truth. And that is science of it. Because methane is 40 times worse than CO2. So you don't even need that much of it to do a big damage. And guess what? You don't even want to know how much methane comes off of a damn landfill. So much methane comes off a landfill that they literally will capture it to burn it as natural gas. Because there's that much of it. And imagine the landfills that don't capture it, because most of them don't. And imagine all the oceans, plastic, emitting all that stuff, because there's nobody capturing that. Nobody capturing the ethane and methylene coming off, or methane and ethylene coming off of the ocean plastic, right? So I'm just saying, that's the real stuff going on here. And that's why I can say that this process will actually contribute to the process of solving climate change, because the emissions from leaving plastic in the environment are worse than this process could ever be. Because at least this process, everything is captured, controlled. So even if the emissions coming off this were horrible, guess what? All the emissions are right here, baby, in this bladder. I don't gotta release this. But you put it out in the ocean, it's out there. And it ain't coming back down. And all methane and ethylene are hydrocarbons, so they can be broken down into smaller hydrocarbons, into things that are much better for the environment. That's facts. Combustion is one way, but there's other chemical ways to convert them too. So, the point is, that's where the real focus should be. On practices that reduce the big boys. Not the little boys, the big boys. So the machine's body temperature is at 230 C. So we're just clocking in almost at 500 Fahrenheit body temperature. Once again, that just lets us know this thing is real hot on the inside. Hey, and what did I tell you guys? I told you Nature Diddy wants to party. Like Cat Williams said, Nature Diddy loves to party. I got my oil. Guys. Let me show you the oil, because this oil is looking much better than the last oil we got. Look at that, much better ratio. Much less water, much more oil. What's up, Etheria? Good to see you. You said you can make solar panels from used TVs. I doubt that could be any good though, right? So yeah, oil's looking much better. I'll go pour this out and we'll get some more. Now you probably wonder like, where does all that water go? The water is separated from the oil in a separatory funnel, ran through an activated carbon filter a few times to get all the impurities out. At that point, the water's pretty inert. There's not much in there. The activated carbon absorbs all the organics within the water, and then that activated carbon can be put into the machine itself. Hey, who in here is an OG? Who in here has been here since I've been building the machine? Like since I started welding it, and you guys remember me like collecting the microwaves and stuff. You said, how much does it cost to make a gallon of fuel? We're gonna get those numbers soon. You said, I extracted gold from used TVs, hard drives, and Nintendo Wii. Yeah, imagine putting that stuff in here. You're an OG, Lieutenant Jen. You're an OG, Deem. Hey, what's up, all my OGs? What's up, Rob, OG, Vincent, Pajami? Yeah, OGs. Hey, guys, it's been 3 months. Oh, yeah, of course, Memory. You're an OG always. Hey, can you guys believe it's just been 3 months? 3 months ago, there was nothing here. This did not exist. It's wild. It's wild. It's kind of hard to even imagine that. And then, has anybody been in here since my first reactor? That would be a real OG at that point, because that was almost 3 years ago now. You said don't put metal in there. I can put metal in. This is my microwave. I put whatever the hell I want in here. I make this crap. You say you've been here since Mark III? Oh, you definitely OG. That was like 2 years ago at this point, right? Pretty much year and a half, 2 years. So you remember those days? Dan, you guys are OGs. That's some OGs in here, man. Hey, I love to see it, and I appreciate you guys for the support, always. We're still pulling a 13-inch of mercury vacuum. The machine is vacuum tight, even under temperature. I love to see it. You know, but Facebook says it's slow connection. I don't even know why. I'm on Ethernet. Some bollocks. Couple years we'll all be OGs when you got millions of subs. Yeah, exactly, Andre. And it'll be hard to find you guys. Chat will be moving too damn quick. But we'll remember these days right here. I call out your name on the live stream, Andre. So, yeah, that's where we're at now. We really just, at this point, just have some more trial runs to do. Unfortunately, we're still not at full power, but we will be next run. What else can I do? I can compress more of this gas directly into propane tank. I need to get another propane tank, actually. Thank you, Etheria. I appreciate you. Have you put it in a car yet? Yes. You said I'd shred all the plastic just to ship it to you for the melting process. And that would sure help a lot. The shredding of the plastic is so annoying to me. Because the shredder is like, it's a good shredder, but it has really bad like covers on it. So I have to like stand over it the whole time to make sure it's not about to spew out a whole bunch of shredded plastic. So annoying. So I just took a look at my desiccator and I did see some oils in the silica gel. So that essentially means that my condensers are not getting all of the oils out. So I have to add some more condensers. The good thing is I can do that pretty easily because I have a really good water chiller. So the condensers are constantly cold. The water, it has a good pump on it. So it's just a matter of adding another one to this whole system of pumps. We do have to remember, with the machine under vacuum, the vapors get pulled through really quickly. So we might have to literally make this whole column just a whole bunch of condensers to get every single drop of oil. We don't want any oil missing, because that's gonna hurt our numbers when it comes to the X amount of plastic to X amount of oil yield. If you know, even a few ounces of oil over time will add up to a huge degree. But you know, it's these types of things, trial and error, to make it better. Do you guys think it would hurt it if I added a condenser column up on this vertical part? Because right now all the condensers are coming down on the angle. But if it's vertical, that might reflux it. But it might not, since it's vacuum, right? You guys let me know. Because that's really, I mean, unless I just made this thing extend out way more, the only other place I could add condensers would be on the vertical section. And I don't even think it would reflux much, right? Because the vacuum is pulling the vapors through. Think like a steel condenser. They're all vertically stacked. That's true. You said smaller shredded plastic first on a catalyst like carbon, and then ran through zeolite to further clean the fuel, and then pump the hydrogen to a condenser. You said, hey, what's up, man? Much love to Texas. Dinamita, you were here since Mark 4. Hey, much love to you, Tristan. You're an OG too. What about a second stack? Yeah, so there's a lot of different things I'm thinking about with that. You said, let's see. I had a question. How do you do continuous input without oxygen entering the reactor? So when we get this machine operating continuously, how can I load in plastic without oxygen getting in? Well, it's going to be a double valve system. And then you're going to really have to just kind of see it, because I have to do some big adjustments to it that nobody has seen yet. So I can't even really describe it. You just have to see it. But we're going to have it, no oxygen's going to get in. You say you still have gravity pulling down the atoms. If you keep your high surface area reflux cool, you should be fine. So you're saying that with me putting vertical condensers, I won't lose a ton of oil. Is that essentially what you're saying? Because we want to cool it down to where we get every drop of oil before it gets to the recovery pump. But we don't want to cool it down so much coming up that it refluxes and falls back into the machine and then gets broken down into a gas. Because we still want to collect oil. Now technically we could have a machine that just doesn't make anything but the gas product, and all the oils are just reflux down. But that's a different thing. So do you build other products or just the machine? Just this machine. It's a lot of, it takes up all my time and all my finances as well. Said, Twisted Engineering said, hey Naturejab, nice to see all the donations are going to great use. The machine is looking incredible. Thank you so much, man. And I appreciate everybody that has donated. As you see, it's coming together really well. So much love to all of you, and thank all of you, truly. You said, you're going to come on missing, the elites are going to cancel you. I guess we'll see, right? I really don't care, to be honest. Check out aerogels. Yeah, guys, so I'll look into, let me tell you guys something. This is just fiberglass around the machine. The machine holds heat really well. It will stay hot for hours and hours after it's been run, right? Matter of fact, speaking of heat, the body temperature right now is at 244 degrees Celsius, which is just about 500 Fahrenheit. It seems to be topped out there. Thank you for the $2 donation, Zango Geek on YouTube. Thanks. He said, congrats on the 100K. Hey, thank you, man. Much love to you guys on YouTube. We got the play button, guys. Much love to all you guys. Seriously. I appreciate you all. I'm gonna check something out because I see some vapors. It looks like smoke coming off the back of the machine. I think it's just the fiberglass. That's just getting really hot. But you gotta make sure, right? So this doesn't just blow up all of a sudden. But my vacuum meter is not budging. We're still pulling a consistent vacuum. The vacuum is not breaking, so I don't think it's a leak. In fact, if it was a leak, there wouldn't be smoke coming out. It'd be sucked in. So I think it's just something else heating up. But I'm gonna check. Oh, great. So my the black cover of the insulation on the back of the machine is melting. It's got too hot back there. I don't have a temperature probe to know the temperature of the back of the machine. But obviously it's got to be pretty hot for the heat to go through all this insulation and to melt this up there. Because I can touch this, and this is barely even warm up here. But anyways, guys, what I was going to say is, ever since I've been running the machine under vacuum, it's been amazing. Because you guys know we used to have the leaks from the magnetrons. Like the gaskets would blow. And they blow in two different ways. One, they blow under pressure, they pop up. And then the second way they blow would be oils would condense on the surface of the gaskets of the microwaves. The microwaves would blow up the gasket when they would heat up the oils. Since this is under vacuum, and both of those things don't happen anymore. Because obviously it's negative pressure, so it's not gonna pop up. And then since the vapors are always being sucked out, their vapors are not forming oils on the surface of the the waveguide. So that's not been an issue since. So rock wool insulation for the next prototype. I want to use cow wool, but I can always just take this off. It's not a big deal. It's just a day of work. Thank you for the £1 donation. I'm 1NR1. Much love. Thank you, Blake Raymond. Much love to you. You said, hey, bud, tribute watching you on both platforms. What's up, David Robinson? What else are you watching me on, YouTube? So yeah, we solved that big problem before. All right, so we're still pulling a 15 HG vacuum. We got some more oils. I'm gonna show you guys this oil, and we're gonna call it there for the night. Show you guys this last batch of oil that we got forming, we got cooking right now, and we'll call it there. So I got a few things I gotta adjust on the machine to get the run better. Of course, first things first is fix the other magnetron so we get at full power. Second is to put more plastic in the machine so we get more products coming out. Thank you for the 1,000 HUF. Greetings from Hungary. Much love to Hungary. Thank you so much, X3 on the YouTube. So let me collect this oil. You guys can see the oil. Turn the blades on. Wireless. All right. This is the last oil you're going to see for tonight. Now, the sun is going down at a different angle, but I think that it's pretty fair to say this oil is objectively darker than the oil we got a little bit earlier. Pay attention to that type of thing. The oil we got before was a little bit red, right? A little clearer. This is darker. What does that mean? Heavier fraction. What does that mean? That what we got before may have been more like gasoline. This is more like diesel jet fuel, okay? Even when I put it in the sun, it's not as red as it was as the last batch. So this stuff is a mix. I always tell you, it's a Frankenstein. You're never gonna really get a single type coming out. It's pretty much impossible. That's why you have to refine it afterwards. But there you go. This is the third cup of oil that we made live. You guys saw it. Tomorrow we're gonna make even more. So what does it smell like? Not good. So that's why we gotta refine it. All right, so you guys saw it. Machine is up and running again. I appreciate everybody that has stopped by. And once again, much love to everybody that has made this possible. 100,000 on YouTube. I appreciate you all. And we're gonna come back tomorrow with an even better run, okay? So we made our natural gas. My rectangular and spherical balls are full. Fact. We got oils. Fact. Looking good. Machine has operated good under vacuum, consistent 15 HG, 15 inches of mercury. So a pretty good vacuum. Half a full vacuum consistently. That's good. Check. Power consumption. We were at 98,000 watts for how long? Where's my timer? Oh no, timer went out. How long have we been live, guys? Because the timer went out at 40 minutes. How long have we been live? Where is it? Where's it telling me that? Thank you, Vivi Vulture, Vivu, I don't know how to say your name, I'm sorry. But thank you for the 10 PLN on YouTube. You said, as a biofuel nerd, I love your work. Hey, much love to you. Thank you. You said 1 hour, 20 minutes. So the machine was running for 2 hours. So 98,000 watts, 2 hours. I don't know what that math comes out to. But that's how long, that's the energy consumption with 5 out of 6 magnetrons on and everything else included in there. The recovery pump, the fans, the blades, all of that. So we're gonna get this stuff done. See you guys tomorrow. Thank you very much for, of course, 100,000. And thank you very much for everybody who has donated. You guys make this possible. So much love to every single one of you guys.